Hey guys, I didn't see you sitting there. Hold on just a second, I'm just practicing my casting. Oh yeah. Just getting ready for summer. It's coming sooner than later, that's for sure. Got my my fishing hat on. Got yeah, it's almost fishing time. Got my tropical shirt on, and we are ready. Getting ready for summer, that's for sure. But we're not there yet. A little bit more algebra to learn, and got another exciting lesson for you today, coming to you in your next installment of Learning Algebra with Mr. Bauman from Mr. Bauman's Basement. Welcome back. Only a few more episodes left. Thank goodness, right? We're almost to summer. You can almost see the light at the end of the tunnel. That light keeps getting brighter. The days keep getting longer. The grass is getting greener. I'm running out of things to describe. Your patience with these episodes probably is getting smaller, but you're almost there. We're learning some really good algebra. This is really going to benefit you next year when you get to high school. So we're almost there. We're entering chapter 11, as I promised. I told you, I promised you we'd get to chapter 11. We're going to hit a couple sections in chapter 11, and then we're done. Summer can come at that point. I can go fishing, practice in my backyard. That's why there's a plastic golf ball at the end. Practice my casting in the backyard. Girls and I set up shop there and put buckets out in the yard and just cast away. So anyways, summer is almost here. You're going to need your notebook, definitely a pencil, probably not a calculator today. I've got my supplies as always. I got my whiteboard, got my marker, got the magical eraser. Still haven't understood in like 6 or 7 weeks of using this thing. It's definitely seen its day. I don't understand what's so magical about this. Just like a sponge, really. But again, no good algebra lesson is complete without the old cup of joe. Mighty good. You guys ready? Here we go, chapter 11. Jumping right into it. 11.1, simplifying rational expressions. Simplifying rational expressions. A lot of this vocabulary should sound familiar. We're kind of bringing some things together here that we've learned throughout the year. Our objective, really, kind of twofold. Number one, again, if you need to pause the video at any point, now would be a good time. Be able to simplify these rational expressions, specifically containing monomials, binomials, and you guessed it, trinomials. And secondly, we're going to state any excluded values. That term you haven't heard before, I'm going to explain that here today. So part 2 of our objective, be able to state any excluded value. Last chance to pause the video, get the title and the objective in your notebook. We're ready to rock and roll. Here we go. I'm going to try to keep this streamlined as we can. All right. Now, I mentioned we're going to be looking at a couple different skills here today that you've been using throughout the year. And I want to state what those 2 skills are before we jump into the first example. So, number 1, you're going to be utilizing what we learned probably back in like November, December, called the rules of exponents. We're going to be using that here in one of the first examples, actually. The rules of exponents. So powers. Specifically, if you divide powers that have the same base, what do you do to the exponents? We're going to be examining that here in just a few moments. Number 2, everyone's favorite. We've been doing this probably since, oh gosh, right after Christmas break. Everyone's favorite, factoring. We got to review some of the factoring skills here today in order to be able to simplify these rational expressions. All right, so those are the 2 big hitters here today in terms of skills that you've learned throughout the year that you're going to be utilizing here today. So let's jump right into the first example. And by the way, the directions for each of these examples here today, but also in your Google Doc, are basically going to be the same. So we're going to simplify the expression, and then we're going to state what we call excluded values. State what's called excluded values. So let me go ahead and give you the first expression. And then as you write this down, I want to kind of chat about what it means to be an excluded value. Simplify 35c to the 8th over 5c to the 9th. First of all, we can identify this numerator as a monomial. Even though there's a lot of things being multiplied here, a monomial has one term. Since nothing's being added or subtracted, this 35c to the 8th, that's the one and only term on the top. So this would be considered a monomial. Same with the bottom, or the denominator. This is also a monomial. So we have a monomial divided by a monomial, and we're going to simplify this. But before we do that, let me talk about what this means to be excluded values. To exclude something kind of means to leave it out, to kind of isolate it in some shape or form. So if something is excluded, we don't want to consider it. So when you look at this expression, what's really the only number that you cannot have on the bottom of a fraction? That's right, you can't have 0. So what's the only value of c that would make this bottom equal to 0? Let me restate that. What's the only value of c that would make the bottom, this whole denominator, equal to 0? The only number that I could put in here that would make it equal to 0 is 0 itself. Because if I put in 0 to the 9th, that's 0. 0 times 5 is still 0. So at the end of this problem, we're going to have to state what that excluded value happens to be. All right, but let's go ahead and start simplifying. Let's cover up the variables for a second. Let's just simplify 35 fifths. 35 fifths is just 7. That's right. Technically, it's 7 over 1. Then we have to utilize the rules of exponents. So now I'm going to cover up these coefficients. What's c to the 8th divided by c to the 9th? If you're dividing two powers with the same base, this is what we talked about, like November, December, somewhere around there, dividing two powers with the same base, what do you do to the exponents? That's right, you subtract them. So this would be 8 minus 9 is negative 1. This is a great review from earlier in the year. Can I leave my answer like this? Not a chance. Not a chance. You cannot express these expressions with a negative exponent. How did we deal with that? If you have a negative exponent on the top, drop it down to the bottom. So the only thing that's going to move is the c to the negative 1. It goes down to the bottom. 7 stays on the top. So this would be 7 over c. Technically, it's to the first power. So there's my simplified expression, but I have to state what the excluded value is. We said at the very beginning, the only thing that c cannot be is 0. So the way to state that, write the word when, W-H-E-N, when c is not equal to 0. This is what we call the excluded value. So we're including any number, any real number that you could possibly think of could work for this except 0. So this is your answer, your simplified expression, but you have to state what should not be considered. All right, so that's a monomial divided by a monomial. Again, at any point, if you have questions, as always, shoot me an email. I know some of you are, and that's great. I try to get back with you as soon as I can. Let's move on to example 2. Same directions, simplify, and state excluded values. Sometimes there's only one excluded value, sometimes there's none, but sometimes there's only one, sometimes there's more than one. And let's look at this one. We got a binomial, 3n minus 1 over another binomial, 6n minus 2. 3n minus 1 over 6n minus 2. Again, we're trying to simplify this, put it in simplest form, but also state any excluded values. Let's talk about the excluded values first this time. What's the only number you can't have on the bottom, or in the denominator? That's right, it's 0. If you're wondering why, if you try to divide something by 0, what do you get? You don't get 0, you get what's called undefined. If you try to type it into your calculator, you get an error message. We can't define what that is. So the only thing that this bottom can't be is 0. That doesn't mean that's the excluded value. That's what the denominator can't be. So if we're trying to find the excluded value, take the denominator and set it equal to 0. I'm trying to figure out what number n would make this whole denominator equal to 0. That's the number I want to toss out the window. I don't want that number. So I do a little pre-algebra here. Add 2 to both sides. You get 6n equals 2. Divide by 6. And I got 1/3. So this is just kind of work off to the side somewhere. My excluded value happens to be a fraction this time. My excluded value is 1/3. My excluded value is 1/3. That's going to come into play here at the end of the problem after I simplify it. But let's go ahead and try to simplify at this point. First thing you always ask yourself, is there a GCF? When you're working with binomials like this, is there a GCF up here? Nope. Besides 1, but that's not going to change anything. How about down here? Is there a GCF down here in the bottom? You bet, and it's 2. So let's factor out the GCF. That was one of those skills I was talking about just a few minutes ago. We got to use our factoring skills in order to simplify this. All right, so let's go ahead and leave the top alone for now. Let's factor out the GCF. What is the GCF of the denominator? That's right, rock on. It's 2. And we end up with the other factor would be 3n minus 1. Oh, isn't that cool? Good gravy. We end up factoring, it looks like this. What do you notice? The binomial on the top now cancels with this binomial on the bottom. So these guys cancel. Technically, what do you have up here? You always have a factor of 1. That's right, so this is really 1 over 2. It's pretty cool that this expression you start at the very beginning, it really, in reality, it has a value of 1/2. It has a different look. These two sides of the board have a different look, but they have the same value. It's kind of like the wedding cake we talked about at the beginning of the year. You guys remember that? Same idea. Different look, same value. So your answer would be 1/2 when n does not equal what? When n does not equal 1/3. So tonight on the Google Doc, or today on the Google Doc, I'm looking for this, but I'm also looking for you to state any excluded values. To get the excluded values, take the denominator, set it equal to 0, solve it, that number is your excluded value. All right, it's like tying your shoe, shooting a free throw. The more you do this, the better you get at it. So we're gonna keep on keeping on. I don't know why I keep erasing my directions. It's the same for every problem. Simplify and state excluded values. All right, let's do. Let's change it up a little bit. Do I have that crazy look in my eye? I'm feeling a little crazy right now. Let's do a binomial over a trinomial. All right, let's do 2x minus 8 over x squared minus 2x minus 8. It's pretty amazing how far you guys have come in the last 9 months. If I had shown you this problem at the beginning of the year, you guys would have just tossed your pencils up in the air and said, come on, Bauman, give us a break. I don't even know what you're talking about here. You guys have come a long way. I'm very proud of the efforts you made to get to this point. You're now able to tackle this problem because you know what these polynomials are called. You know how to factor. You know how to apply the rules of exponents, so on and so forth. You guys are ready for high school. So let's go ahead and factor. You probably already, well, I've been chatting away. You probably already factored the top. What's the GCF? That's right, it's 2. And you might have already factored this bottom. We can factor this trinomial into 2 binomials. All right, so let's do that. Let's factor the top. GCF is 2, so that would be x minus 4. 2 times the quantity x minus 4. Now let's go ahead and factor this trinomial. A little walk down memory lane here. Put yourself in the Wayback Machine. We're now back to like January, and in January I gave you this trinomial and I taught you how to factor this into 2 binomials. First term of each obviously is going to be x. Now you're looking for 2 numbers, 2 magic numbers here, 2 numbers that multiply together to give -8 and add together to give -2. Did you find them yet? I believe it's -4 and +2. -4 times +2, that's a product of -8. And if you add these together, the sum of -4 plus 2, oh my stars, is -2. Now, what do you notice? There's multiplication right here. There's multiplication right here. So if I wanted to, I could start simplifying the top and the bottom if there's a common factor. And oh my stars, there's a common factor here and here. So those can cancel. And I end up with my simplified expression would be 2 over the quantity x plus 2. 2 over the quantity x plus 2. So there's your quote-unquote answer. That's your simplified expression. But now we need to state any excluded values. This bottom, this denominator, cannot be 0. That's right, because that's undefined. It cannot be 0. And I could certainly take this denominator, set it equal to 0, and I could do the good old-fashioned quadratic formula here. But that could take a little time. I think there's going to be a little shortcut here. Instead of using the quadratic formula, you might as well use the factored form because you've already done the factoring, right? So if I do the factored form, so instead of doing the quadratic formula, I use the factored form of this quadratic, and I use, remember that thing called the zero product property, which said that either this factor was 0 or this factor is 0. That you should be able to do mentally. What's the only number that would make that factor, x minus 4, equal to 0? It's 4, right? What's the only number that would make this binomial, this factor, equal to 0? It's -2. Those are your 2 excluded values. So you would say the answer, the simplified expression, is 2 over the quantity x plus 2 when x is not equal to 4 and x is not equal to -2. I'll give you a chance to write that down. It's basically what I'm asking you to do on the Google Doc today. All right. And by the way, if you don't believe me, if you take 4 and plug it in here and here, what are you going to get? You're going to get 0. Not allowed. That's why we excluded it. If you put -2 in here and here, you're going to get 0. Again, not allowed. That's why we're excluding those 2 numbers. Any other number on the planet, you could include there. All right. In the words of my famous, my favorite rocker, John Bon Jovi, we are officially halfway there. We just completed page 1 of my notes. We're on to page 2. Rock on, John Bon Jovi's great rocker. You like this hat, by the way? This old hat belonged to my grandpa. I have very fond memories of him going fishing with me, and he always would wear this hat. And believe it or not, like 35 years later, this thing's still working. Put a battery in it today and ticks away. You can probably hear it ticking in the camera. With my tropical shirt on, I'm about ready for summer. I don't know about you guys, but weather's getting nice, and I know you guys are ready to rock and roll with summer, but hang with me for about another, 4 classes? 3 after this one? You guys are almost there. Let's look. Good night. I keep erasing my directions. You guys already know the directions. I keep erasing it for whatever reason. Let's do a trinomial over a binomial this time. So let's kind of switch things up a little bit. So let's do a squared minus 3a plus 2 all over the quantity 3a minus 3. Whoopsh. Simplify and state any excluded values. Simplify and state any excluded values. You know the drill. It's very similar to the last problem we just did, except this time the trinomial is on top. So this probably can be factored. This one definitely can be factored. Why? Why can this be factored? You got it. It's got a GCF, which happens to be 3. That's right. So let's go ahead and factor the top and the bottom. You do yours, I'll do mine. Let's see if we get the same thing. All right, time's up. Here we go. I factored the top trinomial. I was looking for two magic numbers that multiply together to give positive 2 and whose sum is negative 3. I got negative 1 and negative 2. I could have just as easily put the negative 2 here and the negative 1 there for reasons we've talked about in the past. The bottom also could be factored. The GCF is 3. So I factored out the GCF, the leftovers. Remember when we called them the leftovers? The factor that multiplies by 3 to get 3a is a. The factor that multiplies together to get negative 3 is negative 1. So I think this is fully factored. Again, there's a multiplication right here. There's a multiplication right here. So I can just start crossing out any factors that are on the top and the bottom. That's like math you learned as a little kid, right? Except now they're binomials instead of just numbers. So what can simplify? Let's see if I can do this backwards. That and that cross out. So my simplified expression would be the quantity a minus 2 all over 3. Box that in. That's the quote-unquote answer. This is the simplified expression. But what are we missing? We're missing the excluded values. Maybe there is, maybe there's not. So take the denominator, exactly what you're going to be doing tonight. Take the denominator. This cannot be 0. So let's find out what that excluded value is. So if I do take the bottom and set it equal to 0, so I'm just kind of doing this off in the margins of my paper. If I was you, I would do this just kind of off in the margin somewhere. Take the denominator, set it equal to 0, solve it. This is like 7th grade math here, some pre-algebra. Solve this. That number is your excluded value. So if you need to come back to this part of the video when you're doing your work on the Google Doc, please do so. Just doing some real quick pre-algebra here. I got an excluded value of 1. So I go back to my answer. So this is the answer when a does not equal 1. All right, we're getting close. These last two problems are I think the two curveballs in this assignment, in this video. So let's move to those. All right, example 5. Same directions. Simplify it simplify it and state any excluded values. 2x minus 5 over 5 minus 2x. A little bit trickier here. It's almost as if I took this numerator and whoop, kind of flip-flopped it and kept the sign here the same. Now are both the numerator and denominator identical? Do they have the same value? No, they don't. Notice what symbol is here, even though we don't write it. This is a positive 2. But down here, it's a negative 2. The same is true here. This 5 is technically negative 5, while down here it's technically positive 5. So these are kind of like opposites, like opposite binomials here. So you might want to just make a note in your notes. The denominator, I'm just going to abbreviate here if I can spell. The denominator has opposite terms as the numerator. That's really, really messy, but hopefully you can make that out. The denominator has opposite terms as the numerator. Pause your video if you need to. Get this in your notes. You're going to see one like this on the Google Doc here today. Very, very similar. When that happens, when the denominator, all the terms are opposite the terms of the numerator, you're going to have to kind of slow your roll a little bit, put a little pause on the problem. And here's the hint. And I think I even put this on your Google Doc. The hint is to factor -1 from the numerator. I'll put this up on the screen here. I think I spelled that right. I'm not a very good speller. Thankfully, I'm not your spelling teacher. So if this happens, if you have binomials that are opposite of each other, the hint is this: factor a -1 from the numerator. Go ahead and pause your video if you need to. Factor a -1 from the numerator. Now, what does that mean? What does that look like? You might be sitting there thinking, oh, I wrote it down, but I don't know what you mean, Mr. Bauman. Let me show you what I mean by that. In the numerator, so that's the top, you're going to factor out a -1. In other words, what times -1 gets you positive 2x? That's right, it's -2x. What times -1 gives you -5? That's right, it's positive 5. We basically just did like the inverse of the distributive property. The inverse of the distributive property is just factoring. Now, I did that. We learned a long time ago that two terms in a binomial, they can simply be whoop, just flip-flopped. Make sure you take the correct sign with it. So instead of 5 minus 2x, I could rewrite this as -2x plus 5. This denominator and this denominator are exactly the same. I just flip-flop the order here. Why is that allowed? Because technically we're adding. And you learned at a very young age that the order doesn't matter when you add. Now that I've done kind of this little manipulation here, now you notice this is a factor, or the multiplication. That now cancels with that. So all I'm left with is -1. So my simplified expression is -1 when x does not equal, so this is my answer, but I still need to find the excluded value. That's right. So take the denominator, set it equal to what? That's right, set it equal to 0. You guys are so smart. Do a little pre-algebra here. -2x is equal to -5 divided by -2. When x does not equal, I'm going to go ahead and keep it as a fraction. When x does not equal +5/2. If you left it as 2.5, I would take that. Even a mixed number, I'd prefer not a mixed number, but I would take it anyways. So your answer, your simplified expression, is just -1 when x does not equal 5 halves. If you took 5 halves and put it right there, I guarantee you get 0 on the bottom, which is not allowed. That's why we exclude it. Definitely going to see this next year in 9th grade. Whether you take Algebra 1 or Algebra 2, I guarantee you're going to see this again next year. So this is just your first little introduction to simplifying rational expressions. That's good stuff. It almost matches my shirt. Look at that. It's like camouflage. Is there really a coffee mug here? Last problem. I promise. You guys still awake, by the way? All right. Here we go. Ooh, story problem. Everyone's favorite. The old story problem. All right, so let's suppose we have a square. And it has a side. I guess all the sides, because it's a square, all the sides have the same length. It has a side length of 10x plus 2. You could certainly draw it if you wanted to. I just wrote it out in words. A square has a side length of 10x plus 2. On the other hand, a rectangle, so a different shape. Now we're talking about a rectangle. A rectangle with a width of 5x plus 1. Make sure you get that in the screen. A rectangle with a width of 5x plus 1. Again, if you want to draw your own picture, you could draw a square. You could then draw the second shape, this other rectangle, and then label the dimensions if you wanted to. I'm just writing it out in words. Let's suppose that that rectangle and that square have the same area. Okay? They have the same area. That's a key point in this story problem. The fact that they have the same area, that's like, literally, it's like the key that kind of unlocks this problem. The question is, let me get some space here. I'll just use a different board. The question is, what is the length of the what, do you suppose? That's right, the length of the rectangle. I already know the length of the square. It's the same as its width. But what is the length of the rectangle? What is the length of the rectangle? Pause the video if you need to get this question down. All right, great question. This is like kind of has multiple levels here of kind of what we call depth of understanding. So your depth of knowledge is going quite deep here. All right, so let's kind of label this. So let's do the area of the square. I'm just going to call it ASQ, area of the square, just because I want to use symbols because I'm kind of tired of writing words right now. So the area of the square. Do we know that? Kind of. How do you define the area of a square? It's one side times itself. Because it's a square, all the sides are going to be the same. So we know that one side is 10x plus 2. And to find the area, you multiply that by itself. So I know that the area of the square is the quantity 10x plus 2 times the quantity 10x plus 2. Now let's talk about the area of the rectangle. The area of the rectangle, we'll just call it A rect. Area of the rectangle we know the area of a rectangle is length times width. That's from like, probably like third or fourth grade. We know that's true. What separates fourth grade from eighth grade is instead of just numbers here, we now have binomials. So we know the, what do we know? We know the width. We know the width. So I'm just going to erase the W and put in 5x plus 1. So the area of the rectangle is the length, which we're looking for, times the width, 5x plus 1. Now, what do we know about the area of the square and the area of the rectangle? Do we know a number? Nope. But we do know the relationship between these is that they're equal. How do you know that? Because that's what I told you at the beginning of the problem. The area of both of these are the same. So if the areas are the same, then this is equal to this. This binomial times this binomial is the same thing as this L times this binomial. Alright, so let me get a little space here on this other board. So if these are equal, that's what I'm going to write on this next board. Then I'm claiming that the two binomials is equal to L times that binomial. Let's go ahead and isolate L, because that's what I'm looking for, right? So I want to get this by itself. So I have to undo this multiplication right here. How do you undo multiplication? That's right, you got to divide. So I'm going to divide both sides by this binomial. Oh wow, this is a great problem. This is a really great problem. What happens over here? That's right, they cancel. They should. So I definitely end up with L. Definitely end up with L, which is what I'm shooting for, and I end up with this like crazy funky looking thing here. You can probably guess, because we're talking about this story problem in the section 11.1, probably guess that we can simplify one of these, if maybe not but two or three of these binomials here. You notice this one and this one both have a GCF. That's right. What's the GCF here? 2. What's the GCF here? Still 2. What's the GCF down here? It really doesn't have one except the number 1. So let's go ahead and factor out that GCF in both of them. The bottom one we don't touch yet. So all I did here on the top is factored out a 2 from this one. That's how I got 2 times 5x plus 1. And then factor out a 2 on this one. That's the same thing. I got 2 times the quantity 5x plus 1. I didn't touch the bottom. Now, and I'm trying to make these dots real dark. This is multiplication. This is multiplication. Technically, there's multiplication right there as well. Because there's just multiplication, there's just factors up at the top, I can simplify with this denominator. Just choose one of them. I'm going to cancel that with the denominator. So the length of my rectangle is equal to 2 times 2, which is 4, times the quantity 5x plus 1. If you wanted to, you could distribute this 4. If on your Google Doc, if this was the same problem, you could also put 20x plus 4. Would be the same thing. You just distributed the 4. That's a good looking problem. That's a really good looking problem. Again, if I had shown you this at the beginning of the school year, you guys would have been a fish out of water. That was a terrible joke, wasn't it? Speaking of fish, I think the lesson's over. I'm going to go practice my casting out in the backyard, or maybe just here in the basement. But thanks so much for joining me for this this video. You guys have a Google Doc to work on here today. I'll be real honest with you. The problems in the Google Doc are very similar to what we just did here in today's lesson. So go enjoy the weather after you finish the Google Doc. Appreciate you watching this video, and as always, I hope you now know a whole lot more about algebra after watching this video than you did at the beginning of the video. That's my goal every video. So appreciate your time, and as always, continue to be kind to one another. Continue to be patient with one another, most definitely, but most of all, please continue to pray. Pray for one another. Pray for your classmates. Pray for your family. Pray for our world. We all need it. So we'll catch you guys in the next video. We're almost there. We are almost there. Hang in there. Be patient. Have a wonderful day.